Hello guys, I am Dr. Karunlata Shukla. Today's topic is gravitation. In this video, we will find the answers of the following questions. What is gravitational force and gravity of the earth, universal law of gravitation and universal gravitational constants. So let's start. What is gravitational force? We know in the universe, every object attracts every other object. That means this force between these objects is known as gravitational force. And what is gravity of the earth? So the force with which the earth pulls the objects towards the center is known as gravity of the earth or gravitational force of the earth. Clear? Now, to find the value of this force, a law was introduced by Sir Isaac Newton, which is known as universal law of gravitation. According to this law, the force of gravitation of between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay? Suppose we have two objects A and B and their masses are m1 and m2 and the distance between them is d. Then according to the universal law of gravitation, force is directly proportional to the product of their masses. That means F is directly proportional to m1 into m2 and F is inversely proportional to the square of the distance between them. That means F is proportional to the 1 by d square. When we combine these equations, we will find F is proportional to m1 into m2 upon d square. To understand this formula, we take an example. Suppose the masses of the object A and B are 4 kg and 5 kg respectively, and the distance between them is 2 meters. Then the force is equals to m1 into m2, that means 4 into 5 divided by 2 square is equals to 4 into 5 by 4. So we get F is equals to 5 newtons. Now here we consider two cases. In the first case, we increase the values of the masses of the objects and the distance remains same. So suppose the mass of the object A is 6 kg and the mass of the another object is 7 kg and the distance is 2 meters. Then the force for the first case is 6 into 7 upon 2 square. That means 6 sevens are 42 divided by 4. So we calculate this. 4 ones are 4, 4 ones are 4, 0, 20. 4 5s are 20. That means F1 is equals to 10.5 newtons. Now for the second case, the masses of these two objects remain constant, same, and we increase the distance. That means we choose D is equals to 4 meters. For this case, the force is, because masses remain same, so we choose m1 is equals to 4, m2 is equals to 5 and the distance between them is 4. So 4 square is equals to 4 5s are 20 by 4 into 4, or 4 into 5 upon 4 into 4, so 1 is cancelled, 5 by 4, that means 4 ones are 4, 1.4 2s are 8, 4 5s are 20, that means 1.25 newtons. So F is equals to 5 newtons, F1 is equals to 10.5 newtons and F2 is equals to 1.25 newtons. That means clearly we see here F is greater than F2 and less than F1. That means when distance between the objects increases, then the force decreases, and when the masses increase, then the force also increase. Clear? Okay. Now we choose a proportionality constant and put here. So we will write F is equals to G into m1 into m2 upon d square, where G is known as universal gravitational constant, or by rearranging this equation we will write G is equals to F into d square upon m1 into m2. Here the value of G, that means value of universal gravitational constant, does not depend on the medium between these two objects and their masses or the distance between them. So suppose the masses of these objects are 1 kg each and distance between them is 1 meters. Then by this equation we get G is equals to F. That means the universal gravitational constant is defined as the force of gravitation between two objects of unit masses and separated by a unit distance from each other, placed anywhere in the space. Clear? So G is equals to F, and for SI, and to find the SI unit of G, we write here, we will write here SI unit of G is equals to SI unit of force is Newton, SI unit of distance is meter, and SI unit of mass is kg. So the SI unit of gravitational constant, universal gravitational constant, is Newton meter square per kg square, and the numerical value of this universal gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This value was found out by Henry Cavendish. And the direction of this force, so direction of this force is along the line joining the centers of these two objects. Clear? Okay, thank you.